Hello and welcome to this review on some trigonometry problems presented to you by the fifth group of MECC 481P1C2. So for our first problem, a telescope set up 40 meters from the base of a vertical chimney reads 3230 with the crosshairs set on the top of the chimney. With the telescope level, the vertical rod at the base of the chimney is 7.95 meters. Approximately how tall is the chimney? So first, we would have to convert the telescope reading into its respective decimal values. And to do that, we simply input the reading 3230 on the calculator and press again the uh, time or minute reading conversion to get a value of 32.5. Finally, after that, we can recall that the tangent of an angle is equal to the opposite side divided by the adjacent side. So upon substituting the values in the figure, we see that the tangent of 32.5 is equal to the height y divided by 40 meters, wherein we can solve for y, which is approximately 25.4828 meters. And finally, we can solve for the height of the chimney by adding our previously solved y with the vertical height of the rod of the telescope, which is 7.95. So finally, we get a height of a chimney of approximately 33.4328 meters. For the second problem, a mechanical engineer wants to determine the height of a chimney tower. He takes sight at the chimney of the top of the chimney from A and B, which are 58 feet apart at the same elevation on a direct line with the chimney tower. The vertical angle at point A is 30 degrees and at point B is 40 degrees. What is the height of the chimney tower? So to visualize, we can represent it as such. So we have the first viewing angle at 30 degrees, point A, and the second viewing angle at 40 degrees, point B, and A and B are 58 feet apart. We can say that the height between the length between B and the chimney tower is x, and the height of the chimney tower is h. Now, we note that the tangent of 30 degrees is equal to h, or the opposite over the adjacent, which is 58 plus x. And we can rearrange that equation to express it in terms of h. And we also have the tangent of 40 degrees is equal to, again, opposite over adjacent, h over x. And we again express that in h. And since the height or the opposite side of both viewing angles is the same, which is h, then we can equate both sides to h using the respective equations solved previously. Using this, we are able to solve for the value of x, which is approximately 127.9327 feet. And finally, we simply substitute that value of x to any of the two equations we have created at the top. And we can say that h is equal to x times the tangent of 40, and finally get the height of the chimney of 107.3483 feet. Sorry. Next, find the solution of secant x minus 1 is equal to tangent x. This is quite a simple problem. We simply have to input the equation into the calculator, and we are able to shift solve it, and it gives us an answer of 0. Next, a tree 150 feet, 54 feet tall casts a shadow 234 feet long. What is the angle of elevation of the sun? We are able to express this image in this problem in this image, wherein this is the angle of elevation of the sun, and this is the tree in the problem. And the angle of elevation, if we are to create another triangle to express the shadow of the tree, we see that the angle of elevation is equal to the angle x here, if we recall our geometry and trigonometry in high school. So we simply have to solve for the angle of x using the dimensions of the tree and its shadow. We can then say that the tangent of x is equal to the opposite over adjacent, 154 feet over 230 feet. And then we can solve for x, which is the inverse tangent of 154 over 30. And we finally have an x, or the angle of elevation of the sun of approximately 33.8049 degrees. Then we have number 5, determine the number of triangles possible with the given parts. A is equal to 126 degrees, side A is equal to 20, and side B is equal to 25. Now, since the A, or capital A, is equal to the opposite angle opposite of side A, then we can say that capital B is equal to the angle opposite of side B. Now, if you were to observe a random triangle with side x and opposite angle of theta, we can see that as x increases, theta also increases. Therefore, since side B is greater than A, then angle B should be greater than A. But then again, if we try to sum up angle A and angle B, it becomes angle greater than 180 degrees. And since the interior angle of a triangle is only 180 degrees, therefore no triangle can be formed using these given parts. So I now give the floor to my fellow presenters.
So for the sixth problem, a wire supporting a flagpole is anchored 14.03 meters up from the base of a flagpole. It makes a 15-degree angle with the ground. So then what is the length of the wire in meter? So from this problem, we can obtain a figure in which we can see here the flagpole is 14.3 meters, 03 meters high, and there is the angle of 15 degrees. So knowing this, from this figure, we can say that sine theta, as we could call, is the opposite over the hypotenuse. So rearranging, we can get the value of the hypotenuse, which is the opposite over sine theta. So simply substitute the values. So the hypotenuse equals the height, which is 14.03 meters over sine 15 degrees, which is approximately 54.2078 meters. So the next problem. Roberto has to find the area of the gable end of a house. Find the area of the gable if it is a triangle with two sides of 44.58 feet that meet at 105-degree angle. So from here, we can see from the picture or the figure, there is the angle A, C, and B, and their corresponding lengths of the side. So knowing that to the law of cosines, C squared equals A squared plus B squared, which are the sides, minus the 2 times side A and side B cosine the angle C. Rearranging again, we can get the value of C, which is simply the square root of the given equation. So substituting the values, we can get a value of C, which is approximately 70.7354 feet. So knowing that this is an isosceles triangle, we can use the Heron's formula in order to directly get the area. So from S equals A plus B plus C over 2, you can get the value of 79.9477. And then another equation for the area, which is the square root of S times the difference of S minus A times S minus B times S minus C. Substituting all the values, we can get the area approximately 959.8289 feet squared. So for the eighth problem, the lengths of the two sides of a triangle are 11 and 15. Which of the following is the possible length of the third side? So for this problem, there's actually two possible scenarios, which in the third side may be the longest or the shortest. But based on the given values of the problem, we can conclude that the third side is actually the shortest side, since all of the given are less than 11 and 15. So recalling Schwartz inequality, 11 plus x is greater than 15. So substituting the choices, the only answer that is possible is D, which is 5. Next problem. If sine alpha equals x, what is sec alpha? So noting that sine alpha equals the opposite over hypotenuse, we can actually create a figure from that certain equation. So sine alpha equals x, which is the opposite over the hypotenuse. So from the figure, we can get here, which the side opposite is x, and the hypotenuse of 1. So because we can assume that the denominator of x is naturally 1 since it is x. So by Pythagorean theorem, the given figure or the obtained figure, c squared equals a squared plus b squared. So substituting the values from our figure, 1 squared equals x squared plus b squared, we can get the value of b or the adjacent side, which is the square root of 1 minus x squared. So simply knowing the relation of secant alpha is the hypotenuse over adjacent. So from the figure, we can get 1 over the square root of 1 minus x squared. And for the 10th problem, what is the distance traveled by the tip of the clock's minute hand during 20 minutes if the minute hand of the clock is 16.84 cm long? So from the problem, it is given that the minute hand of the clock is 16.84 cm, which we can assume is the radius of a full circle. So noting that the distance traveled for one full revolution is just the circumference. So the circumference is equal to 2 pi r. And then noting that 20 minutes is 1/3 of a full revolution since one full revolution is 60 minutes. So 20 minutes over 60 minutes, we can get 1/3 of the whole revolution. So from this, we can get the distance, which is the circumference or the full revolution over 3. So it is equal to 1/3 times 2 pi r. Substituting the value of the r, which is 16.84 cm, we can get an approximate distance of 35.2696 cm. So proceed to the next presenter.
For the next problem, problem number 11, find the area of a triangle formed by joining the centers of 3 circles with radii 3, 5, and 9 centimeter if they are externally tangent. So this is the illustration for 3 externally tangent circles, and by connecting their centers, we can form a triangle denoting side A, side B, and side C. So by analyzing the figure, we can make measurements for every side. So side A is the sum of the radius of circle 3 and the radius of circle 1, which is equal to 12. Side B is equal to the sum of radius of circle 3 and the radius of circle 2, which is 14 centimeter. And side C is the sum of radius of circle 1 and radius of circle 2, which is 8 centimeter. Now we can use the Heron's formula to solve for the area. First, we will solve for S, which is equal to A plus B plus C over 2, and substituting all the values, we can get 17. Then to get the area, we have here the formula, square root of S times S minus A times S minus B and times S minus C. And substituting all the values, we can get 47.9062 centimeters squared. For problem number 12, what is the perimeter of an isosceles triangle if the base is 40 centimeter and the base angle is 70 degrees? So this is the illustration for the isosceles triangle. If we divide the triangle by half, we can get a right triangle which has a base of 20 centimeter, or just the you divide 40 by 2 since it is an isosceles triangle. Then we will solve for the hypotenuse. So by using the trigonometric function cosine, we can get cosine theta is adjacent over hypotenuse. And here our theta is 70 degrees. And by rearranging this, we can get hypotenuse is equal to adjacent over cosine theta. By substituting all the values for the adjacent side and the theta, we can get 58.4761 centimeters. So this is the length of the hypotenuse. Since the perimeter is the missing of this problem, the perimeter is just the sum of all the sides. And the hypotenuse in the left side is just equal to the hypotenuse of the right side, since this is an isosceles triangle. By summing up all the sides, we can get 156.9522 centimeter. For the next problem, problem number 13, what is identically equal to secant A plus tangent A? So by using the trigonometric identities, secant A is equal to 1 over cosine A, and tangent A is equal to sine A over cosine A. Now for the next step, we can equate 1 over cosine A to cosine A over cosine squared A, and sine A over cosine A is equal to cosine A times sine A divided by cosine squared A. So you can check it, because if you manually eliminate the common terms, you can go back to 1 over cosine A and sine A over cosine A. Then by combining this new formula that we have, new equation that we have obtained, we can get cosine A plus cosine A times sine A divided by cosine squared A. Now for the next step, we can factor out cosine A from the numerator. So it will become cosine A times 1 plus sine A divided by 1 minus sine squared A. Now for the denominator, we can factor this out. By using the concept of the difference of two squares, the factor for the denominator is 1 plus sine A times 1 minus sine A. That is why we can extract 1 plus sine A from the denominator and 1 plus sine A from the numerator. And we can cancel this out. So the equation will be cosine A divided by 1 minus sine A. And the next will be by transferring the cosine A in the numerator to the denominator, we can get 1 over 1 minus sine A over cosine A. And by separating the denominator function, we can get two equivalent terms, which is 1 over cosine A minus sine A over cosine A. Now, we know that 1 over cosine A is equal to secant A, and sine A over cosine A is equal to tangent A. So therefore, secant A plus tangent A is equal to 1 over secant A minus tangent A. So this is how to derive the secant A plus tangent A. So next is problem number 14. You found two angles to be complementary. One of the angle is half the other angle. Find the smaller angle. So we denote A and B to be the angles. So if they are complementary, meaning A plus B is equal to 90 degrees. For the second statement, one of the angles is half the other angle. So angle A is equal to half of the other angle, which is 1/2 B. By substituting the equation 2 to equation 1, we can get 1/2 B plus B is equal to 90. And by solving this, we can get B is equal to 60 degrees. But the problems is finding the smaller angle. So we need to ensure that the other angle is the smaller. So by substituting B to equation 1, we can get A is equal to 30 degrees. So by comparing, the smaller angle is 30 degrees. Therefore, 30 degrees is the answer for this question. So problem number 15, find the area of a triangle whose side is 15 centimeter, 11 centimeter, and 5 centimeter. So for the area of when the three sides of triangle is given, you can use the Heron's formula. First, you will solve for S. S is equal to A plus B plus C divided by 2. And substituting all the values, you can get 15.5 centimeter. And the formula for area is equal to square root of S times S minus A times S minus B times S minus C. By substituting all the values, you can get 19.1360 centimeters squared. Then for the problem number 16, in the figure below, A is equal to 15 centimeter, B is equal to 5 centimeter, and angle A is equal to 60 degrees. Find the value of angle C. So we will use in this equation the sine law, the law of sines. So by the sine law, we equate sine A over A to sine B over B, and we will solve for angle B. By rearranging this formula, we can get B is equal to the arc sine of B over A, small b over small a, times sine of angle A. By substituting all the given, we can get an angle B of 16.7787 degrees. And the problem is finding the angle C. And we know that for a triangle, the sum of interior angles is equal to 180 degrees. And we are given now with two angles. Therefore, we can solve for angle C, which is equal to 180 degrees minus angle A minus angle B. Then substituting all the given, we can get the angle C of 103.2213 degrees. So that is all for our problems, and thank you for listening.